So here is a quick summary of the convection heat transfer. Just to bring out a few points, one really cannot go by the summary. There's lots of details and one needs to see in the respective sections and cannot depend on just the summary. So we learned about something called the boundary layer, and it is the layer where the heat transfer happens. So here, in case of flow over a flat surface, thermal boundary layer is this thickness here over which the fluid temperature goes from surface to the bulk fluid, from the surface to the bulk fluid. It's a very thin layer, but that's where all the action is. Higher the velocity, thinner the layer. The complex process of heat transfer in a fluid is described by fluid flow equations and, of course, the energy equation. So this being quite complex, we want to replace all of that by this magic called H. So we have to define it properly, and we have to realize that H then includes all of these flow effects and heat transfer effect, which means factors such as flow geometry, type of flow, all that is included in H. So it is not some sort of a material property. It really characterizes all the details of the flow. And therefore, H depends on many factors. First, the geometry, whether it's a flat plate or cylinder or sphere. Those are the three types of geometry we discussed. Then the type of flow, whether it's a natural convection or forced convection. Then what is the nature of the flow? Is it laminar or is it turbulent? Then are we interested in a local value or an average value over a surface? So there are equations for all different combinations of these conditions. So when we're trying to choose an equation for H, we have to be extremely careful because H really takes care of all of these effects: the geometry effects, the type of flow, the nature, laminar or turbulent, and everything. And finally, two of the most important types of convective heat transfer are natural and forced. The driving forces are quite different. Velocity is forced in one, and it happens due to temperature difference in the other. So the characteristic numbers that show up in the formula are also different. When the flow is forced and we know the velocity, then it is the case of Reynolds number, and it's for forced convection. When we do not know the velocity and flow is really driven by temperature gradient, as in natural convection, then we use Grashof number. Prandtl number is the same in both cases. So this is perhaps the two biggest classes of flow is in case of heat transfer is natural convection and forced convection. We need to be careful as we are choosing the formula or trying to find the right H. Okay.